got to have the infrastructure right. It's got to operate correctly. And so if you're like, well, I'll just throw it into AI and I'll hope for the best. Well, the thing is, if you're throwing all of your information in all at once, so let's say I have a huge paper and top to bottom, it's 100% of that I just threw it in. Well, what if you need information at the 10% mark, the 50% mark, and the 90% mark? The reality is that when AI looks at your information, and especially as it gets longer, so if you're over like 64K context windows, most people are looking at like literally a million as a context window, you get what this thing is called a U shape. And the U shape, think of it like staring into a pond, a murky pond. To be able to see the bottom in a murky pond is near impossible, and that's what you're asking the large language model to do. So you can only see what's on the shores, and
Right. You
that's
see on
not
the
enough
edges.
indicator. Yeah, you can
Right.
only see the edges, you can't see the middle. And that's exactly how it works with these large language models. And so you end up having to you have all these other techniques to try to cut and figure that out. And it's like, well, instead of doing this big long thing, we'll do it in chunks. Okay, I'll do it here, 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 here. Well, you still have blind spots in those U's. And so you have shallower depth that you have to deal with, but you have many things spread apart. And then trying to piece that back together is near impossible. And so that's why we built what we built for consulting, so we could just get it done, be done with it. And then there's also like tons of other different ways to do it, like embedding models, which is, I think, okay. It gets the job done, but it's not great. It just says, this is generally what you want. And it's like, no, I need a specific detail. Please provide the specific detail. Then you have to reprompt it. And so you end up becoming the person that has to go and find the information anyway. It's very much like a delivery service, like trying on clothes that you didn't go to the store to get fitted for. You don't know what your fit is, so you're guessing. So you're going to have to order it, wait for it, and then send it back potentially, and then wait for it again. You kind of have this
Back and
vicious
forth
loop.
thing.
That's really what most of these companies are dealing with right now, and they haven't figured out the infrastructure because they're using traditional AI methods, and they're expecting their older traditional regular methods to work with traditional AI methods, and both are incompatible.
So what I'm hearing is this murky pond, we have all the data and we can see the shore that's close to us and we can see like what's on the other side, but the middle is problematic. So let's make a bunch of little ponds and then it won't be as deep and we can process this data through a bunch of little ponds. And while that might be a better approach, there's still wiggle room, there's still inaccuracy. The data is still not being handled the best. And so based on your research, they left out some key details that could really have affected the deal.
Correct. Yeah. So I call it the net approach. So the net approach is where we'll say it's using the pond approach. It's like, let's say you, for instance, you're looking for fish, right? And you're looking for a specific type of fish in the pond. You don't want to hurt all the fish and you don't want to mess up your data. So what you end up doing is literally casting a net, finding exactly where those fish are, and but you end up pulling them all in as a copy of that and say, okay, I don't need these fish. And then you only have those fish, and then you redraw the context of where they're at. So you use both the original and the copy combined, a net approach, which is actually very useful. But at the end of the day, it takes more time, it takes more resources to find that, but you end up cutting a lot of the errors out of the process.